In this video, I'm going to solve the equation x squared plus x equals y cubed minus y, and y squared plus y equals x cubed minus x. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to solve this system with two approaches. My first approach is kind of more direct, which is to just subtract the two equations. So we will have x squared minus y squared plus x minus y, and that equals y cubed minus x cubed minus y plus x. Now notice that the x minus y and the minus y plus x are actually the same, so they cancel out. And so all we have left is x squared minus y squared equals y cubed minus x cubed. Next, I'm going to move y cubed minus x cubed to the other side. So both parts start with x. And then for each part, there's a common factor of x minus y. I'm going to take it out. So either we have x minus y equals 0, and that means x equals y, or it's the other expression that equals 0. Now if x equals y, then the whole thing is quite easy, because then from the first equation we know that x squared plus x equals x cubed minus x. So we have a cubic equation, but actually it's just quadratic because there is no constant term. We can take out the x. So x either equals 0, or 2, or minus 1. And that means we have three solutions here. Either x and y are both 0, both 2, or both minus 1. Then we can move on to the other case. Apart from saying that x plus y plus x squared plus xy plus y squared equals 0, we also have the fact that x and y are not equal. Then we can go back to the first equation. Observe that for these three terms, the first equation tells us this, and we move only the y to the left. The first three terms that I've highlighted is just equal to y cubed. So y cubed plus xy plus y squared equals 0. So we can take out the y. And again, we have two cases. The first case is y equals 0. Second case is y is not 0, but then x equals minus y squared. So for y equals 0, we can say that x squared plus x from the first equation equals 0. And that gives x equals 0 or minus 1. So we have one extra solution, which is minus 1, 0. But by symmetry, we can actually generate one more, which is 0 and minus 1. Now for the other side, x equals minus y squared. We can put that into the first equation again. And we have minus y squared all squared minus y squared equals y cubed minus y. So simplifying, we first expand for the left, then we cross out the y squared, we cross out the minus y, and we have y cubed times y minus 2 equals 0. So y equals 0, y equals 2. Of course, we can reject y equals 0 because that has already happened in the case at the left. Well, for y equals 2, that means we can say x squared plus x is 2 cubed minus 2, and that's 6. So with a quadratic again, either we have x equals minus 3 or x equals 2. So for x equals 2, we've already got it. But for x equals minus 3, then by checking in the second equation, we notice that but then y squared plus y will be equal to minus 27 minus negative 3. So y squared plus y plus 24 equals 0. So there is no solution. So that means this case gives solution, but not new ones. So altogether, we have these 5 solutions. Double 0, double 2, double minus 1, minus 1 and 0, and 0 minus 1. So these are the 5 solutions that we get. So this is the first approach. Here is the second approach. Notice that for the 2 equations, I can actually rewrite them as, for the first one, x times x plus 1 equals y times y squared minus 1, and I can further factorize, which is y plus 1 times y minus 1. Whereas for the second equation, I can factorize both sides and get y times y plus 1 equals x times x plus 1 times x minus 1. Now if we multiply, which should still hold for the equality, we have xy times x plus 1 times y plus 1 at the left, while for the right, we have the exact same expression at the left, further multiplied by x minus 1 times y minus 1. So if I move the expression at the left to the right, then we have a common factor, which is xy times x plus 1 times y plus 1. And also it's multiplied by x minus 1 times y minus 1 minus 1, and the product equals 0. So this quickly gives lots of solutions. Say when x equals 0, and we know that y squared plus y equals 0, y equals 0 or minus 1, and then we also have y equals 0, which, using a similar argument, should give x equals 0 or minus 1. Now for x equals minus 1, which arises from the factor x plus 1, and that should give y cubed minus y equals 0. So y equals to either 0 or plus or minus 1, and similar argument on the case y equals minus 1. And the rest will be x minus 1 times y minus 1 equals 1. And from this, I'm going to make y the subject of the equation, which is y minus 1 equals 1 over x minus 1. And so y equals x over x minus 1. Then from this, I'm going to put this into the second equation. And so we have x over x minus 1 all squared plus x over x minus 1 equals x cubed minus x. Then I'm going to do some algebra so that there will be no denominator, no fraction on either side. Expanding the left, we have 2x squared minus x, while for the right, we have x cubed minus x times x squared minus 2x plus 1. For the right, we have x to the power 5 minus 2x to the power 4. For the x cubed, we have plus x cubed from plus 1 times x cubed and minus x times x squared, so they vanish. For the x squared term, we have plus 2x squared only. Finally, for the term of the lowest degree is minus x. So simplifying, we have x to the power 5 minus 2x to the power 4 equals 0. So either x equals 0 or x equals 2. So for x equals 0 is done already. While for x equals 2, we have y squared plus y equals 6. So again, we have two solutions. Y equals minus 3 or y equals 2. Again, we can do some checking and reject the solution. So from this method, we have the same 5 pairs of solutions again. Please feel free to share ideas in the comments. Thank you for watching. See you next time.